Hi, I'm Ms. Cho, and today we're going to solve systems of linear equations by graphing. We've already seen before when we have two equations, like negative 5x plus 7 is equal to 4x minus 2, we can find the solution by graphing each side separately. We set each side equal to y, we put them on the same graph, and we look for their intersection. When we have different equations that we're considering together, we call this a system of equations. And their intersection is called the solution to the system. The solution is all points that make all equations in the system true. We can classify systems of equations by how many intersections or solutions they have. When we have one solution, we call this an independent system. And this is when your lines look like something like this. We can have zero solutions in what's called an inconsistent system. This is when your lines are parallel and they never meet. So there's no point that lies on both lines. We could also have infinite solutions. This is called a dependent system. And this is when you have a line where your second line ends up being your first line in disguise. You didn't actually have two different lines, you only had one. Let's take a look at some examples. Here, I'm thinking of two numbers that add up to 5. I can write that as x plus y is equal to 5, where x and y are my different numbers. And then my second condition is that one number has to be 4 times bigger than the other. So let's say my first number is 4 times bigger than the second one. I can graph this by rearranging and putting it into point slope form. So y is equal to negative x plus 5, and then this becomes y is equal to 1/4 x. So here in Desmos, I have y is equal to negative x plus 5, and then I have y is equal to 1/4 x. Remember the x has to stay out of the denominator. And that gives me one solution at 4, 1. So in order to check algebraically to see whether this is a solution, I have to see whether it makes both my equations true. So my first equation was x plus y is equal to 5. And so my x value here is 4, my y value is 1, and I want to know if that equals 5. 4 plus 1 is 5, and 5 equals 5. So that means my first condition is met, and I'm good so far. Now I have to check the other equation. So x is equal to 4y. And my x is 4, my y is 1, and I want to know if 4 is equal to 4 times 1. 4 is equal to 4, so then that means my second equation has been satisfied, and I do have a valid solution at 4, 1. Let's take a look at a second example. Here I have an inconsistent system. I have y is equal to negative 1/3 x minus 4, which is already in point slope form. And then this other one, negative x minus 3y minus 9, needs to be rearranged. So I'm going to add an x to both sides. And that will give me negative 3y is equal to negative 9 plus x. I divide through by negative 3. And that gives me y is equal to positive 3 plus a negative 1/3 x, or in standard form, y is equal to negative 1/3 x plus 3. Sorry, point slope form. So if I graph these, I have y is equal to negative 1/3 x minus 4, and y is equal to negative 1/3 x plus 3. And as you can see, my lines here are parallel. They never meet, and they have two different intercepts. So algebraically, what I want to show is that these two lines have the same slope, different intercepts. And recall, in slope-intercept form, y equals mx plus b, our slope is our m, and our b is our y-intercept. So I can see that my slopes here are minus 1/3 and minus 1/3, but my intercepts are different. I have a -4 and I have a +3. So these are parallel lines and there's no solution. Our last example is a dependent system. I already have one in slope-intercept form, and then I'm just going to rearrange the other one. So I'm going to subtract the 6x from both sides. That leaves me with 3y is equal to 15 minus 6x. I'm going to divide through again by the 3. And that gives me y is equal to 5 minus 2x, or y is equal to -2x plus 5. But wait, this is the exact same line as what I have here. And so I can go to Desmos and see that y is equal to -2x plus 5. Y is equal to -2x plus 5. It gives me one line right on top of each other. If I wasn't sure if I did the math correctly, I could actually type this in standard form. This 6x plus 3y is equal to 15. And we can see again that this is the same line, and there's not actually a second line. So there are infinite solutions because any point on the first line is also on the second line. So for dependent systems, we want to show that they are the same line. And so that's what we did here. You know, y is equal to -2x plus 5, and y is equal to -2x plus 5. If you have more questions, please let us know. We'll see you next time.